Thanks a lot. Yeah, so I thought we'd start off by having a look at an example. You've probably heard of Discourse. It's a forum application built by one of the co-founders of Stack Overflow. And we're going to take a look at it as, I guess, being one of the founders of Stack Overflow. They're doing all the right things, the current best practices. We've got client-side rendered. We're using CDNs. It's gzipped. It's minified. It's concatenated. All those fantastic bits and pieces. So I'm just going to leave this kind of running as I talk about some of the challenges we're facing with performance these days. So if you see this site, Discourse, okay, we've tapped. We're waiting. So modern phone, modern tools should be doing something. Hopefully we're actually playing the video. Yeah, okay, fantastic. We finally loaded. Now there was nothing faked about that video. That is exactly what you do if you grab yourself a pretty mid-range Android phone at the moment and tap on Discourse. This is not a beginner team. This is an expert team. This isn't people using weird old tools. This is people using brand new tools. This is actually an Ember site, but I'm not picking on Ember particularly. Now perhaps it's just like a one-off. We're going to look at some other examples and just kind of compare. This is Discourse versus a very niche forum. This is a forum written by one person for a niche language called the D programming language. So we have on one side Discourse, a venture-funded, Greylock and First Round Capital, expert-developed site versus a one-man web forum in the D language. So here we are. And this is server-side rendered. So we're going to go, tap, bang. We immediately get back. And you might say, well, server-side, fine. The first page load is pretty brutally fast, but it's going to have a terrible page-to-page speed. And again, let's actually just test this. Let's have a go. So here we are. And here is our server load. It's doing a full page reload every single time. And you can see we're getting sub 100 milliseconds on 3G. All of the demos today are going to be 3G for a reason I'll explain later. And you might say, OK, but that was a pretty good site, fine. But the client side is going to smoke that. It's going to absolutely annihilate it when we go to page on Discourse. Like once it's downloaded our amazingly fast client-side rendering, it's going to smoke the D-Lang forum. And again, here we are. New phone. Click. OK, well, we've loaded. We can at least go back fast, right? That's a special move of single-page app. Click. What is going on here? Well, what I would say is that we're really good as programmers at working out what should be the best way of doing things. And we go and talk to them about them at conferences, and we say, here is because of this reason and this reason, deductively reasoning why everyone should be building client-side apps for everything. Once we downloaded them, they're incredibly fast. Who wouldn't want incredibly fast page-to-page speeds? But if we don't test our beliefs, we're going to come a cropper. It's the basic rule of science is be humble. Test things. And this is where I think Discourse has probably gone wrong. I'm not trying to pick on Discourse. I think it's a great forum. It does really, really good job when you're on desktop. Fantastic. But I think they pick their tools without much empirical testing. I'd like to quickly demo what would happen if we did do some empirical tests on Discourse and do something that hopefully, well, how many people do this? How many people test their sites on a real device with a USB cable? Pretty good. Maybe a half, it's quite hard to see. So anyway, if you haven't done this, DevTools, it's all just native in DevTools. Go to More Tools, Inspect Devices, stick in your USB, and you'll get this. You can have a look at all the tabs on a device with Chrome. You can do very similar things with iPhone. And let's have a look at what we're going to kind of find when we get tracing. OK, so we're going to go and we'll have a look. We'll have a graph like this. And you'll immediately see something that's a bit weird in that we're not getting much activity after the first kind of 50 milliseconds. This is actually on iPhone 6. This is not a slow device. We can see there's six blocking scripts at the top of this. And some of those are taking a good 2 seconds to load. Now, that's a good explanation for the first bit of the kind of incredible slowness of the Discourse site. But the thing that really intrigued me was how the page-to-page speed was so bad. And if we go down deep into the timeline view and start analyzing, what we see on a tap is a very small initial event, and then the page re-render. And the page re-render on I'll explain more about this phone that I'm using. It's not a crap phone. Is taking 2 seconds to generate that JavaScript. Sorry, generate the HTML. This is not a bad phone. It's a quad-core phone. It's a gig. It's very recent, this year release. And it takes 2 seconds to render a page of HTML. OK, Now, there are probably those among you who are saying, like, you're making this sound a lot worse than it is. And one of the things you're going to say, well, you were testing on 3G. And you say, well, 4G's here, and 4G's incredibly fast. And I'm here to say, I'm sorry, that's just not true. First off, 4G is coming. In the UK, we have a lot of stuff branded as 4G. Some of it's 3.5G. Some of it is just 3G. And most of the time, you must design for 3G. It will continue to be out there for at least a decade. It's just too expensive to replace all of that hardware. So a lot of your users and a lot of your own use is going to be on 3G. And if we actually dig into how 3G works and understand its performance characteristics, you're going to understand why shoving hundreds and hundreds of kilobytes of JavaScript to the page before you render anything is going to make a terrible experience. It's not because of bandwidth. It's because of latency. Because of big pauses before you get a single byte down to the phone. And the fully paid kind of initial latency of a 3G connection to a server, cold, is around 2 seconds. Maybe more. That's your kind of minimum, because you're going to have to do a handshake with the tower. Then you're going to have to go and do your DNS lookups. The handshake to the tower can easily take this 2 seconds. Then you have to do DNS lookup. Then you have to do your TLS handshake, your SSL layer handshake. Then you have to transmit your bytes to the server, get the bytes back, go through all of those steps again. Hope you haven't moved cell, because that would take another incredibly complicated set of lookups to locate your phone again. And eventually you get those bytes to the server, to your phone. And then if you're doing client-side rendering, you have to do the entire thing again, minus a few handshakes, hopefully, to get your AJAX loaded to your device. So design for 3G taking around 2 seconds. Now, why does it take all this time? Why is the latency so high? Well, we cannot have the radio on our phones on the entire time. Mobile devices are designed to stay idle as much as possible. So when you're not actively using the radio, it will shut down. And if you don't, you'll run the device's battery all the way down extremely fast. Only the screen is hungrier in terms of power use. So obviously, if your user is looking and you're using both the screen and the radio at the same time, you're going to wipe out their power extremely quickly. And because of this, you're going to get involved, you create an incredible amount of latency at every single step. So your application may do a fetch, but then it has to turn on the radio, wait for the OS. The radio and the the device have to start discussing when it's actually going to do some transmission. It can't just transmit straight away, et cetera, et cetera, et cetera. And of course, it's added to all of the normal, completely non-guaranteed latency in the internet. So what can we do about that? Well, the first thing is we need to understand that this problem exists. So many people just test their devices on either localhost, which is obviously completely not a good way to test anything, even with the emulating slow networks. We need to have empathy for how this network works. How we design applications is often effectively a torture test for the network. So if you look at a typical kind of very small chunk of HTML, huge chunk of JavaScript, which then makes it a ginormous request for AJAX, that is going to give you a first frame very, very far down the line. And then we'll let the radio go idle, and then we'll kind of grab another kind of chunk of AJAX. We do pagination or whatever. So we're going to do lots and lots and lots and lots of AJAX requests. And actually, pagination in that style is going to be extremely poor performance in a 3G environment, because you give it enough time for the radio to go idle, so the next time you ask for the next page, you're going to have to do all of that handshake, et cetera, et cetera, et cetera. So this is the design which is completely kind of network agnostic, designed by someone who doesn't have any empathy with the network. If you start to have empathy with a 3G network, this is probably what you're going to end up with, which is going to be a big chunk of pre-rendered HTML coming down to the device very, very fast, probably with some embedded data for the next interactions, probably with some inline styles, probably with some inline JavaScript to handle the initial bits and pieces. And that can actually be quite chunky, because the thing is, once 3G or 4G gets connected, it's pretty fast. The bandwidth isn't really the problem. So you can push quite a lot of data in that initial load without having like such a horrible cost. And then after the users see that, then you can load in your big chunky JS framework, et cetera, and start making some AJAX calls. And if you have a look at comparison between the first frame, which is the green arrow, and the more content rendered, they've gone into dashed lines here. You can see how much faster we're going to end up. And the other important thing is you can see we've cut out the entire second handshake, because we've pushed down enough data in this kind of network empathetic way to handle the next interactions, which are often quite easy to predict. Cool. If you want to get really deep into this stuff, have a look at the AT&T ARO app. This actually lets you look at things like the radio state, kind of toggling on from low power to high power and back again states. Really, really cool. We won't have time for that today. So developing network empathy is a really, really useful skill for designing fast web applications. Really recommend you do it, and that involves using crappy 3G connections as much as possible. Second thing people might say is, you're just using a terrible phone. This is not that bad. You must be using like a phone from like 2009 or something. And I would say to you, no, I'm using a bog standard average phone. This is the phone you should be designing for if you care about average users all over the world. This is the average price of that people pay for a smartphone, the Android smartphone around the world, and you can see in 2016 it's $215. If you go and have a look at the best sellers on Amazon.com, you can see a $60 phone is the best-selling device. You see all of the top 6 on this page are, I believe, all under $100. I did some empirical testing, actually went around Camden High Street, went in and out of lots and lots of phone shops, great way to celebrate Saturday. And this is what I was recommended for what I would say would be quite a large part of the demographic. Someone who just wants to use WhatsApp, maybe Snapchat if he's feeling trendy, bits and pieces. This is what is recommended. None of those phones are the flagship phone. None of those phones are the kind of phones that we probably have in our pockets as geeks. So you can see we're getting like a Samsung J3, even these own-branded phones like the Smart 7. So this is the phone I've actually been recording all these demos for. It's £80, 1 GB RAM, quad-core, recent version of Android, and it's actually amazingly good. When you use it, there is no lag in the UI. Come and ask me afterwards and have a go with the phone. You'll be really surprised. Like I've been an iPhone user for a while, but if I lost it, I would happily just buy one of these phones if I didn't have to go on the web. Because our web apps are giving us a bad name, we will see. And further than this, if you want to see a terrible phone, have a look at this. It's a £20 smartphone. And you can see that in the last day, 40 people have bought it on the Argos website. Now, people do buy these because they are cheap, and they still work. They can do the basics. But they can't do anything on the web, which is kind of our fault. So for an example, this terrible phone, this isn't even the kind of average person's phone, terrible phone, it can do a 3-second initial paint on GitHub, which is a pretty complicated web application, lots and lots of HTML to the page. It cannot load discourse. Like it cannot. I've tried about 10 times. It crashes every single time. But it can play Cut the Rope. It just boggles my mind. A forum. It's just a bunch of text in boxes. It cannot render this, but it can play this game. This is embarrassing. And again, we don't have device empathy. We don't really understand what costs. Like we kind of even forget that things like parsing JavaScript is a non-free operation. Just taking that string of characters, tokenizing it, parsing it, building an AST, and then interpreting it is a non-trivial operation. Even on pretty good phones, just putting stock jQuery on the page will take you 120 milliseconds simply to parse it down. Now, more recent phones, more recent iPhones, are incredibly fast at JavaScript. But even recent Android phones struggle with big, chunky frameworks like Ember. This stuff has to be tested. Now, sorry, this has been quite depressing, so it's time for a pretty good example. Now, here again, stock phone, average phone, and we're going to be looking at Reddit. We're going to be checking out our OCamls, and we've loaded up Reddit nice and fast, and then we're going to do a second page load, and you can see it is a client-side rendered app, and the second page load is pretty nice and fast. And you can see it was smart. It didn't reload any data. It had some initial data, which it used to render, and then it pulled in the next bit of data, like the big comment thread, etc. Now, this has been designed with someone with some network empathy, which is pretty cool. I guess the only thing I'd say that maybe you could go even further, maybe you could load the first 5 comments of every single one of those. It would be something to test, like it would depend. It's one of those things you just have to test, but it's pretty good. It actually kind of does smart things. And it uses the power of our platform, the platform we all share, the web. It does things like an inline rendering for the first kind of chunk of content. Like it does inline styles, which obviously are not best practice for entire applications, but they are best practice if you want to make things fast, which is a bit of a recurring theme. They've done things like inline the logo. Now, a bizarre point of discourse, if you look at the graph, the network flow graph, a big thing that stands out right in the middle is their logo is hosted on a separate CDN. And if it's on a different CDN, that means a different domain name, which means a new DNS request, which means an incredibly weird experience where you see the entire page load and then the logo load, which is the first thing in the eye line of the user. Whereas if you just embed this tiny little image directly as a data URL, no second HTTP request, and definitely no second set of handshakes for DNS, etc. Go further, inline the first interactions, so that if you are, you want someone to click on an article and go through to a link, you don't need an entire client-side framework to toggle a piece of UI from normal state to loading state. Inline that stuff. It will be fast. It will be fast. It gzips down small. If you want to make a really, really fast website, this is what you need to do. If you have a look at Google, you have a look at the Google search results, there is a ton of inline styling and a ton of inline JavaScript to handle that first couple of seconds on a low-end device to give a good experience. And also, don't forget that HTML was designed to be fast and designed to be fast on old, slow modems. So it does progressive rendering. You can push down an HTML page in many, many chunks. You can keep pushing chunks as long as you want until you close down the HTML and close off that initial TCP connection. You can, if you want to do weird things like push data to the page in that initial TCP connection, which is actually a pretty cool technique. So you can see over here, I've got an Express app that's pushing down the fast start with inline rendered, inline styling, all that kind of good stuff, and then it pushes down some data. And don't forget the basics. I don't want to labor this point. You're all experts here. But of course, you want to gzip. Of course, you want to minify and all this kind of stuff. And of course, you want to put things like async tags so that your script tag does not block the page load and will be deferred until the end of the script. Now, there's too much to go into here, but of course, check out like the Google developer docs on how to optimize the kind of basic ways. And then there's kind of, again, even more intriguing ways. If you're really trying to get every ounce of speed out, you can do things like delay parsing. As I said, parsing is non-free. So this over here, you can see I've changed the script tag to something other than JavaScript. If you have no type, it'll be fine. But you said I've just said, leave me for later. The browser's going to ignore that. It has no way of parsing that, which means it's just plain text. It's going to be completely ignored. It's not in the render tree anyway. So you can push data over there for free in a CPU sense. And of course, when you're pulling down huge chunks of data, do not parse it all in one go. That will ruin the experience again because it's a synchronous operation. It will block the main thread. Do it in a stream. And everything I say today, like there are no rules. Performance is one of those wonderfully empirical things. Whatever crazy techniques you use, it's fine. Whatever works, whatever's fast. And this is really where engineering starts. Like it's not just enough to find tools that we find fun and useful, Ember, Angular, whatever, React. If they're not fixing the problems our users had, then we're not really engineering. Install is the killer feature of the web. This is the only place we really be native. All of this time between the first paint below, which is the optimized route, and the first paint above, which is the kind of developer-friendly route of everything in the client-side rendering kind of single-page app, is lost potential for our platform, the platform we share. If we make it a bad experience for people, then they're just not going to use web apps. They're going to go to apps as their first kind of thought. Performance is all about the trade-offs. And so one of the most surprising things for me about Discourse is how badly its solution and its problem match. You need to think about where you can be slow, because obviously doing all these clever optimizations is non-free as well. And if you need to think about what your application is. Like a pure information app, like a Reddit or an Imager, needs to be fast to load. Whereas something like Photoshop or Emacs, you're sitting around in all day, can have a really long load time. No one's going to care. It amortizes over the entire day. Don't optimize that. Whereas if you're building something that's going to be used all day, if you're building a heavy, like an email client or something that people are going to be sitting around in their browser all day, again, only optimize interaction. That page-to-page time becomes extremely important. So if we think about the problem of Discourse, which is a forum, it's very, very heavily read. It's all about short visits. And the solution, you can see that they basically have no relation. And I would really aim for some overlap between those two circles. Makes for a better Venn diagram, and it definitely makes for some happier users if your problem and solution kind of inform each other. Cool tools are definitely means to an end. But what we're trying to do is get fast web apps so people trust the web as a platform. And I started the talk by asking how fast can web apps be, but I really think it's become a point where we have to ask, like, how fast must they be? Because the web is not going to kind of stick around forever if we don't take care of it. And I think we're actually driving people and businesses to go native. Because the thing about performance is it's not just a one-time cost. People are very smart. Like, this is the part of the lizard brain. If something takes a cost, we optimize for it. If we find something slow, we will not use it again. Google did some amazing research where they artificially slowed down Google's search results. And they found that the training they were doing to their user that Google was slow persisted for 7 weeks. They used Google less. Every time they went to Google, they made fewer searches. We're effectively teaching aversion to the web when we make our applications slow. And we've done this once before. And I say we, but you know what I mean, the community. And I don't think we can afford to do it again. Like, people did notice. Business journals like Forbes talked about this, that HTML5 was too slow. And that scares people, and it scares people who make the decisions about what we as developers can use in the future. And we're seeing new threats, I guess, to the tools that we love, the open web. We're seeing things like Android instant apps. Monopolies are how people make money, and monopolists will monopolize. The original vision Microsoft had for the internet was a completely closed garden. And what I think we're going to do if we kind of miss this second opportunity we're getting with progressive web apps, service workers, by kind of avoiding the basics of getting a fast page load, good experience on low-end devices, is we're going to end up with two options, Android or the Apple App Store. We're going to have to pay for the privilege to develop in either of these closed gardens because no one's going to trust the web anymore. So what I've kind of talked about today is start off with how fast it can be, but really I think this is the standard we should be aiming at in all our applications to make sure that we can be web developers in a few years' time. Thank you.